This is the review portion of your Tuesday assignment. So in case you need a little bit of help reviewing what expressions are before you take the domain test, this is the place you should be. So I'm going to go through the expressions portion of your study guide. It kind of skips around a little bit, but you should be able to match up the sections on the study guide that I'm about to go through with you. So expressions deal with rational versus irrational numbers. So first we need to review what those even are. So right here, your rational numbers are any numbers that can be written as a fraction with an integer on the top and on the bottom in the numerator and denominator. Examples of rational numbers are your whole numbers. Those are the counting numbers that you can count on your fingers. Fractions, repeating and terminating decimals. So if your decimal goes on and on and on in a pattern, that's called a repeating decimal. And if your decimal comes to a stop, like 3.2 or 5.16, that's called a terminating decimal. Another example of a rational number are your perfect squares and your perfect cubes. We didn't really talk about cubes in our class, but that's okay. Perfect squares are your numbers like 16, 25, 36. There are many, many others. Those are your numbers that have a perfect square root. When you plug it into the calculator, it works out pretty. Irrational numbers are your decimals that never end. They carry on and on with no particular pattern. They do not terminate, but they also don't repeat. They do not have a pattern. The other irrational numbers are your non-perfect squares. So like if you were to plug in the square root of 5 in your calculator, you're going to get some crazy long decimal answer. That is an irrational number. Pi is also an irrational number, 3.14, and it keeps going forever and ever with no particular pattern. We talked about closure in this class, so the sum of an irrational and rational number is always irrational. So when you mix and match them, when you are adding, you're going to get an irrational answer. Then right here, the product, so when I multiply any rational number that isn't 0 with an irrational number, again, I'm mixing and matching. When I multiply them, I'm going to get an irrational answer. However, if I add or multiply two rational numbers together, I get a rational answer. Let's take a look at what we can do with some of the radical expressions. So these are expressions that have a square root symbol in them. If I want to simplify 3 times the square root of 700, I need to break down that radical first. So what you want to do is take your square root and you're going to see, hey, what can I use to multiply to make 700? So I know that 700 is the same thing as 100 times 7. And then I can split those two radicals apart. So I have the 3 on the front didn't change. The square root of 700, I've broken that down to be the square root of 100 times the square root of 7. And I'm going to look for anything that works out really, really nicely. So the square root of 100 is 10, because 10 times 10 is 100. So that simplifies down really, really nice. And then everything else stays the same. I have 3 times 10 times the square root of 7. And if I want to simplify it even further, 3 times 10 gives me a 30 outside the radical. Then that square root of 7 is still stuck inside, but that's okay. It's okay to have something stuck inside. If it's not a perfect square, it can't come out. Now let's try adding and subtracting radicals. So your note right here says that the number under the radical must be the same. That makes them like terms. So in this first example, 3 square roots of 6 plus 4 square roots of 6, that's going to combine together to make a total of 7 square roots of 6. And that's the way that I would leave the answer. Now this one's a little bit different because my radicals do not match. 7 square roots of 5 minus the square root of 125. I'm going to need to break down that other radical to see if I can somehow get it to match the square root of 5 that I've got in the first piece. So I'm going to take the square root of 125 and rewrite that. I know that 25 times 5 is 125. So I'm going to do some simplifying work right here. I also know that that can be broken apart. And I'm going to go ahead and copy down the rest of the problem. I had 7 square roots of 5 up here and a subtraction sign. And now I'm going to simplify anything that works out nicely. The square root of 25 becomes 5. And I'm going to copy down the rest of the problem that I didn't change. So now I have 7 square roots of 5 minus 5 square roots of 5. 7 of something minus 5 of that same thing leaves me with 2 of them. So my final answer here, when I simplify all the way, would just be 2 square roots of 5. And then when you multiply radical expressions together, this is the easy one. They don't have to look the same. You just multiply inside with inside and outside with outside. So I'm going to go look for everything that is, let's do outside the radicals first. I've got a 4 on the outside. There's an imaginary 1 up in front of the square root of 3, an imaginary 1 in front of the square root of 5. 4 times 1 times 1 gives me 4. And then I'm going to have a radical. I'm going to multiply everything that's under the radical together. So I have a 2, a 3, and a 5. 2 times 3 times 5. Well, 2 times 3 is 6, and 6 times 5 is 30. So my answer would become the square root of 30 right here. And I have a 4 on the outside that isn't changing. My final answer right here would be 4 square roots of 30 when I multiply that radical expression. We also talked about the parts of an expression. So we talked about things called terms. Terms are your big chunks of stuff. So in this first one right here, 3x is a term, and 5 is another term. 2 terms, that makes this a binomial. We'll get to that in a second. We also talked about factors. Those are the things that are being multiplied together. So in 5 times x to the third power, my factors are 5 and x to the power of 3. And then in my next little piece, I have 2x and y that are also being multiplied together in this second term right here. Those are called factors. So in my first term, 5 and x to the third, those are 2 factors being multiplied together. In my second term, 2 times x times y, so 2x and y are called the factors. Your coefficients are the numbers that are being multiplied in front of your variable. So in this example, it would be the 5. And constants are your terms that contain only numbers, no variables at all. So it would be this positive 5 and this negative 2. Those are called constants. So if I wanted to identify these things, the terms, coefficients, and constants of this expression right here, it would look a little something like this. My terms are 5x squared, negative 3x, and 8. The coefficients are being multiplied with my variables, so that would be 5 and negative 3. And my constant is the number that does not have a variable attached to it, just the 8. We also talked about greatest common factor. So when I'm looking for the greatest common factor, or the GCF of an expression, I want to break it down in 2 ways. Let me move that line up a little bit. I want to look at the common factor of the coefficients and the common factor of the variables. So I'm going to come through here and underline my coefficients, 3, 6, and negative 15. The largest number that I can divide out of those 3 underlined numbers is a 3. 3 can be divided by 3, so can 6 and negative 15. So I'm going to pull out a 3 or divide out a 3 from everything that's in that expression. If I look at the variables, I have x to the third, x to the second, x to the power of 1. So I want the most number of x's that I can take from everybody. Since my lowest power is right here at the end, x to the power of 1, that's the most x's I can take. I can't take more than what I have. And in this last term, I only have an x to the power of 1, so I can only divide out 1x. In class, we talked about putting the leftovers in parentheses, so we're going to go ahead and do that. When I take 3x to the power of 3 and divide out the 3 and divide out an x, I'm left with x squared. When I take 6x squared and I divide out the 3 and I divide out one of the x's, I'm left with 2 and one of the x's. And then in my last term, negative 15 divided by 3 gives me negative 5. And then this x divided by x gives me nothing left over, so I'm done. Now this question just said identify the greatest common factor. So technically your answer is just 3x, but I went ahead and finished it out by factoring all the way. We did talk about how we can classify polynomials by the number of terms. You can have 1, 2, 3, or 4 or more terms, and here are the words that we use to describe those things. And we can also classify our polynomials by the degree, or the highest power. When we multiply, we can either distribute through or do something called the FOIL method. I'm going to do this first one by distributing. So I'm going to take 2x and multiply it by x squared. I'm going to get 2x to the power of 3. And then I'm going to take that 2x and multiply it by 3x, and I would get a positive 6x squared. And then I can also take that 2x in the front and multiply it by negative 4. I would get negative 8x. And that's it. Now on this next one, when I FOIL, there's one extra step. So we're going to do the first terms first. So that would be the 5y times y. That gives me 5y squared. And then the O in FOIL stands for outside. That's going to be the 5y and the positive 4. The I in FOIL stands for inside. That's the negative 2 and the y. And then the L in FOIL stands for last. That would be the negative 2 and the positive 4. And then all I would do is come through and take this beautiful rainbow colored expression right here and simplify anything that is alike. And my terms that are alike are the 20y and negative 2y. That would combine together to make 18y. So my final answer would be 5y squared plus 18y minus 8. When we add polynomials together, we are combining the like terms. So it means that our coefficients don't really matter, but we have to have the same variable with the same power. So 8x squared matches up with 5x squared for a total of 13x squared. 9x matches up with negative 2x for a total of 7x. And then negative 4 matches up with our other constant, positive 8. Negative 4 plus 8 gives me an answer of positive 4. So this entire thing right here would be our answer when we add those together. We can also subtract polynomials. You subtract them just like you add them, but there's one extra step at the beginning. You have to address the minus sign that's between the sets of parentheses. So we're going to actually change that minus to a plus, but then flip the sign of everything in the second set of parentheses. So my 14x squared is going to become negative 14x squared. My positive 2x is going to become a negative 2x, and my negative 5 is going to become positive 5. And now I'm going to come through just like I did on the adding example and combine my like terms. And after you combine the like terms, this is what you get right here as your final answer. So that's just a quick overview about what we talked about with expressions. Your domain test might contain different questions, of course, but this is hopefully just a decent review to help get you started.